Did your Arduino mysteriously crash after weeks? In this video I show you what happens to your Arduino after 49 days of operation. Watch now to save your long-term projects. So what could go wrong and why specifically after 49 days? The troublemaker is Arduino's millis function, which returns the number of milliseconds since Arduino powered up. The problem, it overflows after reaching this number. I'm not gonna spell it. When it happens, it suddenly jumps to 0 and starts counting up again. Why such an oddly specific number? It's because millis returns an unsigned long data type, which has 32 bits. This dramatic jump from a very high number back to 0 is where things get interesting. Let's first look at common ways to use millis in your projects and then see exactly how this overflow causes unexpected behavior. For this video I'm using my Arduino Uno R3. First, let me show you a very simple example. I will start a serial connection. I will then print the value of millis and wait for 1000 milliseconds. So this is our output. We get a new message approximately every 1000 milliseconds. Why do we see this deviation? Well, because it doesn't exactly take 1000 milliseconds to run this. So now I would be interested what happens if we see the overflow. I don't expect any problems at this point, but I would like to see what happens. So now we would have to wait 49 days, right? Or we just manipulate the value of millis. And by the way, don't try this at home. You could try this at home, but don't make this a part of your project because this is definitely something you shouldn't do. It will certainly break other libraries and things. So this is just to show you what happens. I create a new function called setMillis, and the goal of this function is to set the millis timer to a specific number of milliseconds. So it takes an unsigned long new millis, and inside there the first thing that we need to do is we need to immediately disable interrupts by calling this function, because otherwise Arduino might update this value at the same time and then we corrupt it and who knows what happens. So let's just disable the interrupts. The next thing is we need to access the variable where the value of millis is stored in. So how can we find out this variable? Well, if we hover over millis and if we command press millis, we jump into the definition and we see that it's an unsigned long function. It returns the value of timer 0 millis. And so this is exactly what we need. Timer 0 millis. So we need to change this variable right here, like this. But if you run it, it will fail. It doesn't work because timer 0 millis wasn't declared in this scope, because it's declared outside of the scope. So we need to tell our compiler that it is declared somewhere else. And we do this by using extern. We also need to add volatile, because this tells the compiler that this variable can be changed outside of this scope. And then unsigned long timer 0 millis. Now the compiler should be aware of this variable. And this works. That's good. So let's add one more thing. We need to enable the interrupts. And now I can use this function. So let's set millis to 10 seconds and see if it works. Yes, that looks great. So we jump directly to 10 seconds. But 10 seconds is nowhere close to the overflow. We need to get as close as possible to the overflow so that we don't have to wait 49 days. So let's set it to 0x. So this is hexadecimal. 1, 2, 3, 4, 5, 6, 7, 8. This is the maximum number, and I will make it a little bit smaller. This should give us about 4 seconds until the overflow occurs. So this now sets it to a very high number, and we get this very high number, and here we overflow. And you see, nothing bad happens with this code. It just overflows, and then it continues with the low number. So after 49 days, this is what would happen. Millis can be used to write non-blocking code. If we want to do multiple things at the same time, seemingly, then we need non-blocking code. And one way of doing it is by using the value of millis. So we would do something like this. I would store an unsigned long old millis value, and then I check if millis is bigger than old millis plus my delay. So for example, 1000. So this code is horrible. Don't use it, and I will show you why in a minute. We can now remove the delay and insert this here. The code is not yet working because we need to, of course, assign millis to old millis. And now we have multiple issues. We're using millis twice. We're using millis here, and we're using millis here, and we're using millis even more than twice. We could do something like this. Current millis equals millis. And this will be an unsigned long variable. And then we use this current millis here instead of the millis. Semicolon, of course, the same deviation. Why? Because we're checking if it's bigger than. So it's bigger or equal than. Yes. Okay. At least it looks good now. So as you can see, it keeps running perfectly fine. Let's assume that you use this for a real world application. For example, you apply some medication to your patient every second, and after 49 days, the patient dies. Why? Let's assume that old millis almost overflows. And by adding 1000, it actually does the overflow. And then the result of this calculation is a very tiny number, something below 1000. And so current millis, which at the time is very high, is definitely bigger than the result of this calculation. And this is true for up to 1000 milliseconds. And during this time, whatever is written in here is going to be executed and executed and executed and executed as fast as possible, over and over and over again. Let me show you. If we set millis to this very high number and run this code again, then we get this. Did you see that? So during this period here, this stays true. And if we increase the baud rate, it looks like this. So this is very bad, and you need to avoid this. The proper way of writing non-blocking code is by doing it like this. We take the current millis and we subtract the old millis and check if it's bigger or equal than our time delay. And this completely fixes the code. Let me show you. If this video was helpful, please like and subscribe to the channel. Check out my smart home room sensor project if you're interested in this kind of stuff. Thank you for watching. See you in the next video.